Okay, so now we're going to look at bounded area. So problem 6, sketch the bounded area between the two curves y equals 9 minus x squared and y equals 0. Well, you should recognize 9 minus x squared as a parabola headed down. Vertex occurs at 0, 9, and it intersects the x-axis at minus 3 and 3. All right, so a rough sketch looks like that, not necessarily drawn to scale because this vertex is a little higher. All right, so the area bounded between the two curves, I really want this area right in here. Okay, and so when you think about a definite interval, it becomes what? Since that curve is above the x-axis, the integral is going to compute that area as positive, and the way I could set it up then is the integral from minus 3 to 3 of 9 minus x squared dx. But if I notice the symmetry of this problem, it's symmetric with respect to the y-axis, so in fact, I could just integrate from 0 to 3 and multiply by 2, and that might simplify my calculations a little bit. All right, so I get twice the integral from 0 to 3, 9 minus x squared dx. So now I need to integrate 9. I get what? 9x. If I integrate x squared, I get x cubed over 3. So I get what? 9x minus x cubed over 3 evaluated between 0 and 3. So if I plug in the top, I'm going to get what? 27 minus 27 thirds times 2. If I plug in the bottom, x is going to be 0, so that all goes away. And now if I clean things up, what? 2 times 27 is 54. 27 divided by 3 is 9, and 2 times 9 is 18. So I think I get 54 minus 18, and if I've done my arithmetic right, that's 36. So there's the area. Okay, now let's look at number 7. Here I have this function, 3x to the 4th plus 2x cubed plus 6. I want to figure out the intervals where the function is, in this case, decreasing. Well, remember, the function is decreasing if the first derivative is negative. So I take the first derivative, which is 12x cubed plus 6x squared. I can factor out a 6x squared. I get 2x plus 1. I need to figure out where this thing is positive or negative. Well, this is always non-negative, so it's only when this changes sign, and that's positive greater than minus 1/2 and negative less than minus 1/2. So here is a graph, if you will, a number line, where the derivative is positive and negative. All right, so where is my function decreasing? I can answer that question. It's decreasing where the first derivative is negative. That's from minus infinity to minus 1/2. And like your convention in Calc 1, we're not going to include the endpoints. Now, if I'm interested in the intervals over which the function is concave up, I'm interested in the second derivative. So I have to take the first derivative and I take one more derivative. I get what? 36x squared plus 12x. So that turns out to be 12x times 3x plus 1, factoring out at 12x. I draw my little number line again. Now I'm going to be determining where the second derivative is positive and negative. So it's 0 at what? When that's 0, and that's x equals 0. And when this is 0, and that's x equals minus 1/3, so I put those 2 points on there, 0 and minus 1/3. If I pick a point over here on this far side, it's easy to see that's positive. As I cross over 0, this is the only factor that changes, so this becomes negative. And as I cross over minus 1/3, this factor changes sign, and so I get positive again. So where is the function concave up? The point is where the second derivative is positive. That's from minus infinity to minus 1/3, and from 0 to plus infinity, these two places. Now, if I'm interested in finding the x values corresponding to inflection points, then the inflection points occur where the function changes concavity. So here it is, concave up to concave down, so x equals minus 3 is an inflection point, and concave down to concave up again, so x equals 0 corresponds to an inflection point. Now those minus 1/3 and 0 are just the x values of the inflection points. The actual inflection points are minus 1/3, and then I have to take that and plug that into my original function, which is up here and kind of ugly. I claim that if I do that, I'm going to get an inflection point of minus 1/3, 161/27, and another inflection point at 0.6. Obviously, if I plug in 0 here, I'm going to get a y value of 6. All right, now I'd like to find x values and classify the extreme points. Well, let's go up and look at the first derivative. My function is increasing into minus 1/2 and decreasing out of minus 1/2. So it's decreasing in and increasing out. That makes minus 1/2 an absolute minimum, right? So x equals minus 1/2 is an absolute minimum. What is that absolute minimum? I'd have to plug in minus 1/2 again to this ugly function up here, and I claim when I do that, I get a value of 95/16. Okay, 8 is a problem where I tell you what the derivative is. F prime is cosine x, and f of pi halves is 3. Find the function. All right, so first off, if the derivative is cosine, then f is sine x plus c. I just integrated. If I know f of pi halves is 3, then 3 is equal to pi halves, and that's sine of pi halves plus c. But sine of pi halves is 1. That tells me c is 2. And that tells me that f is sine x plus 2. Finally, 9. I have this function x squared minus x minus 12 on the interval from 0 to 2. So I have a continuous function on a closed and bounded interval. I know I have an absolute max and an absolute min. How do I find them? Well, first I have to figure out the critical values. So I check the critical values, and I also check the endpoints. So the critical values occur where the first derivative is 0 or undefined. The first derivative is 2x minus 1. It's never undefined. And it's 0 at x equals 1/2. And not only that, it should be easy to see that the function is decreasing into 1/2 and increasing out. That makes 1/2 an absolute minimum. And so to figure out what that minimum is, I would need to plug it into this function. So minus 1/2 is going to be what? Or x equal 1/2 is going to be what? 1/4 minus 1/2 minus 12. So that's like minus 1/4 minus 12, I think minus 49/4. My absolute max is going to occur at one of the endpoints, which one is 0 and the other is 2. So I plug them into my original function. F of 0 is minus 12. F of 2 is 4 minus 2 minus 12, which is going to be minus 10. I pick the one that's bigger, that's minus 10. That's where my absolute maximum occurs. And that is all I need to say about that worksheet.